right, gentlemen, thanks for being with us here at the Intel booth at Embedded World. It's exciting to be with you.
Thanks for having us.
Yeah, don't worry.
One of the hot topics here at the show is physical AI. It's kind of a new term a little bit in the industry. What does it mean to your customers?
I think physical AI for us is a new term, but it's something that our customers have been leveraging for some time. If we think of physically actuating on data, leveraging AI models, and that's quite a profound difference, and it brings a lot of value. If we're here at Embedded World this week, we hear a lot about industries like robotics, but there's actually a lot wider opportunities in many industries that we serve. I'll give you an example, actually, just of one customer.
Great.
We work with Nantrum AI, and they work in the commercial building space. And so they're looking to leverage physical AI to look at environmental monitoring, to look at safety and security, to leverage different elements of their fleet, bringing differentiated value and bringing outcomes to that. And I think when you look at other industries, you can go into perhaps, you could look at robotics, as I've said, but also manufacture for lines. You could even look at wind turbines, smart wind turbines, or you look at oil and gas and fleet management there. There's just a huge amount of opportunities that physical AI leverages and then brings to an audience that we serve.
So yeah, it spans a lot of areas at the edge. I'm wondering, we're here in Europe, are there some particular use cases, maybe one or two, that are most popular here?
Use cases that we see in Europe which are popular is basically what we see in industries like manufacturing, smart city, energy, transportation, where trends like locality, data locality, and sovereignty are very important for our customers due to their high regulatory standards and sustainability targets, but also from privacy and policy concerns. Basically, generally over those industries, those kind of topics are very important at this moment. Saving data near or at the plant or actually at the edge where the actions are being done is very important in this region currently.
It's interesting. I think you're absolutely right. Those trends are especially popular here, but are happening everywhere. And they're actually driving, I think, need for more compute at the edge.
Yeah.
I was having another conversation recently where we were talking about how, the idea of a gateway maybe is becoming a little less important at the edge, because you're not just transferring the data to somewhere else. You're actually processing it right at the edge. What does this imply for the kind of solution architecture that people are looking at? What kind of device do they need?
So that's a very interesting point, because I think when we think about deploying at scale, there are two main kind of extremes of why you can err when you start your application. It's either you under-spec your computer and then next year you are running out of resources, or sometimes you throw a lot of hardware on top of it just to solve that issue, which also is not sustainable when you deploy at scale. So I think it's everything about the new architectures that now are possible to have in such a small device with NPUs, with low TDP CPUs that 3-4 generations ago were not there, but now they are here. They can enable to have those workloads run in a very small piece of hardware, and also buys you some future proofing as well. So it's all about understanding deeply the application, the environment, and then you're being able to right fit the hardware to that specific use case.
Makes sense. And you mentioned new architectures. Here at Intel, we've launched some new products here at the show, and recently two products in particular. One is our new Core Series 2 processors with P cores. This product is really designed for the industrial edge. It has time-coordinated computing for that determinism that matters so much. And then our Intel Core Ultra Series 3, codenamed Panther Lake, which has the NPU, the integrated GPU, and the CPU, has great AI performance for robotics and other similar use cases. When you're thinking about speccing things out and you're designing an OnLogic appliance, how do you de-risk that architecture and make sure the customer gets exactly what they need?
That's, I think the key question for everybody who wants to do their industrial scale AI these days. I mean, you really need to understand what each one of your tools can bring to the table now. Back in the day, you only had the possibility to run your AI in a, let's say, slow CPU type of engine, or a dedicated GPU to bring a lot of horsepower, but sometimes you give too much of an overkill to that specific application, right? those new engines that we're talking about now, specifically the Intel Core Ultra, it gives you all that low-end device capabilities because it brings the right tools to the table. The NPU can run very very quick math for AI workloads, while you still have your CPU running or runtime and everything else, while you still have your integrated GPU running the slightly heavier AI workloads, and you don't need anything. You just have a fanless PC, and then you have everything in there, right tools for the right job. On the other hand, this new P-core only processors that you guys are bringing to the market, I'm particularly very excited about this because I see a lot of customers having machine vision applications, and we all know that as long as the hardware is already there to bring the next ages of evolution to the market, the thing is the software of those customers is still relying on P-cores to do the camera, pinning cameras to each core, and having processors with P-cores only for those customers that are still struggling a bit with those. It's very nice. So I mean,
it's a full portfolio where you can get exactly what you need for each solution.
yeah, I mean, I the way I see it, you guys are really listening to what the market is telling you, what your customers are telling you, and that's very, very good for us as OEMs to have that technology available in our products. So it's very, very good.
Well, thank you. So then what are customers telling you about the business value that this delivers?
Well, there's an awful lot of business value. I'd also just highlight from a de-risk perspective, one of the key things you need to look at is also looking at trends. And that you don't, there's a lot of opportunities, but I guess the investment is one of the big challenges, right? If you're in the retail industry with 3% margin, you're not going to be just testing everything and trying to move things in. Right. So you've got to take informed risks. And what I would say from a de-risk was also don't necessarily look at everything to do at once, look at the trends, and then look for repeatable patterns to be able to then implement. Because again, we're rich in data in this world, but the refinement of that data for value, at OnLogic, we talk about what we make possible, and that really is outcomes for customers. And it's so important that we consider our partnership with Intel and also how we show up in the market is about the end customer outcome. And that could be time, that could be safety, that could be many, many different factors into this. But we have to look at the de-risking from a financial, a safety, a security, whichever angle the customer's looking at, that's going to be our priority, and that's the privilege of working with Intel.
Absolutely. So for customers who are just getting started, what's one or two pieces of advice you'd give for them getting going?
I'd repeat that as well. I think looking at those repeatable patterns, I think that's really important. Again, we've got to look at those trends. And there used to be a saying, it's, data's the new oil. Well, you've got to refine that data and you've got to put that to work in meaningful ways that is going to meet the financial envelope of a company. But also having that processing at the edge is also about latency and speed. And so that's another factor that you look at, that you may not have time to send that right the way through the ecosystem back up to data center or not. You might have to make knee-jerk reactions that could have a safety implication or a business implication. If you're looking at a digital sign, you don't wait till things come back to you. If you're in a safe and secure environment, it's because things are happening real time to look after you. So for me, I'd look at repeatable patterns, but sense and respond, not just turn up with a million different options and test them at one time.
I'd like to add to that as well, is that what we see in the market is basically an automatic reaction that when people identify the need to do AI, is that they actually by default throw a bunch of dedicated GPUs or expensive accelerators at it. And very often it's simply overkill. It's leading to unnecessary complexity, to higher cost, and it could even diminish the potential of pilots actually going into projects. And I think that's definitely a piece of advice that we would like to give the market as well, to really right-size the hardware and to see what is actually necessary and to design the configurable hardware to the exact needs of the edge design and the solution that is required.
I think what you're highlighting is you actually make it easier to clear the ROI hurdle to get to deployment if you don't over-spec it from the beginning.
Yeah, definitely.
Yeah, that's the immediate financial implications, what you just described. But there is also, on the technical perspective, there is also the hurdles you have when you try to launch the thing at scale. It's one thing when you proof of concept on your desk in a lab, but when it comes to provisioning those machines, when it comes to for them complying with your internal cybersecurity regulations of your company. All of those things, they can kill an architecture which is not mature enough in the market. So when we stick with mature architectures, with mature product lines and everything of the sort, then you also have that easiness when you are going to scale your proof of concept that you made at the lab. So that's very important to consider as well.
I think we need to acknowledge that the edge is different. There's no one project the same, and customers simply need hardware which is configured to their exact needs. And that's where we basically, as an OnLogic Excel, I think we provide custom configurations for our customers at the edge. And I think that's highly recommendable in order to make sure that you right size your hardware for your exact needs. And that also from an ROE and from an execution perspective, there's no unnecessary complexity in it.
Fantastic. You know, we've been at the edge as Intel for over 4 decades. It's great to collaborate with OnLogic to help our mutual customers and design exactly the right solutions for them, and look forward to continuing the partnership. Thank you all so much.
Thank you.
Thank you.